Okay, I hope my camera's working. I have no idea. I guess it doesn't really matter if it is or not, but I know it kind of helps to see the person that's talking to you rather than just hearing them on the screen. Okay, so I don't usually make lessons that are real personalized, but this one, Callista, is just for you. So I graded some of your papers the other day from math, and I noticed, I sent some back, which I think you got. But I kept some of the ones that I noticed that you had a little bit more trouble on. Some of them you put question marks because you weren't quite sure what to do, and that's okay. And then some of the other ones you just missed. And so before we go forward, I just kind of wanted to go over some of this with you. So I'm kind of contemplating on having you redo a couple of these things before we move on, because there's no sense in moving on and doing anything more until I know for sure you've grasped these main, concepts. So if you would, to get your math book, turn to, well, actually there's nothing in here. This is over chapter 6 in your math book, which chapter 6 was over, I think it was division of fractions. Multiplying and dividing fractions is what it was over. So the page that I have from chapter 6 was the review. It's math 6.6, worksheet 6.6, which was the chapter synopsis. So anyway, okay. So if you'll look at worksheet 6.6, it was letters A and C that you missed. You got B and D correct. So I wanted to go over some of these with you to kind of show you, to make sure you were understanding. Okay, so on A, it gave us, I can't do that. I have got to have it a little bit bigger than that. All right, on A, you had 1/3 divided by 1/4. It gets a little confusing when you're doing this with fractions. And most of the time your fractions, when they're being divided, aren't written this way. But we're in book 2 right now, some of us are. And so I've noticed that some of the ones they're doing now are written this way, but generally they're not. But remember, this line right here means divided by. It does not matter what numbers are on top and bottom. That line means divided by. So if we write this out this way, and I just want to make sure, most of the time when y'all give me your work, you usually just give me your answer, and that's okay. But sometimes I want to see, or at least know, that you're working the problems out step by step. I know when I was in school that my teachers, my math teacher, he was a good math teacher, but he would hand you your paper back if you did not have every single step on every single problem. So oftentimes we had a lot of paper. So this is the same thing as saying 1/3 divided by 1/4. Now, before we go forward, I want you to look back in your actual book where the lessons are, not the worksheets. I want you to look at section section 6.4 in your book, your student book. It's on page 146. Just wanted to go over this with you right quick, just make sure you got it. So it says you can now add, subtract, multiply using the fractional notation. Before we look at our final operation, division, there's a couple of aspects of fractions we need to explore in order to understand why we divide fractions the way we do. You may at first wonder why you need to know these things, but we'll see in the next lesson that they apply to one degree or another every time we divide a fraction using the common shortcut. Math builds on itself, and mathematicians are always looking for ways to shorten a process by making observations about how a notation works with the consistencies God created. Okay, so where it says reciprocal / multiplicative inverse, notice that the second fraction in each pair below is the exact opposite of the first one. The numerator has become the denominator and vice versa. So first you have 4/3, and to the right of that you have 3/4. They just flipped it upside down. Same with 1/2, same with 2/3. They've just flipped the fractions the other way around. Notice that we could write whole numbers this way too. After all, since dividing by 1 doesn't change the value, we can think of any whole number as a fraction divided by 1. We could then flip that fraction just as we did the other. So if you take 2 or 2 over 1, so any whole number, we'll take 4. Okay, if you just, well, for instance, let's say you are, didn't you just turn 14? I think you're 4, or no, you're 13. You just turned 13. Okay, so we say you're 13. Okay, to put that as a fraction, you just say you're 13 over 1. This equals 13. Whatever number is on top, the number is on top, because it's saying 13 divided by 1. 13 goes into, 1 goes into 13 times. So that's why that is. All right, now, I'm nearly at the bottom of this page. What would happen if we multiply a fraction by its flipped version? We'd essentially be multiplying the fraction by its opposite, which effectively turns it into a number divided by itself, giving us 1. So if you have 2/3 times 3/2, which is just the inverse of that fraction, you multiply across, you get 6 over 6. That equals 1. Notice how if we simplify as we solve, both the numerator and denominator always cancel out. So look at the inverse problems. You have 2/3 and 3/2. You see the numbers that are crossways from each other. Each of those goes into each other 1 time. So you just simplify those, cross those out. You get 1 on each side. Multiply across, you get 1. It doesn't matter. It's all the same thing. Now, look at the top of page 147. Although it may not seem so at first glance, knowing what to multiply a number by to make 1 is a very helpful thing. It's so helpful, in fact, that we have a name to describe the number that, when multiplied by another number, equals 1. More than one name, actually. Some people call it the reciprocal of a number, while others refer to it as the multiplicative inverse. I prefer reciprocal. It sounds better and it's easier to say. So long as the context is clear, it's the inverse. Now, in a fraction, the inverse will always be a flipped version of the fraction, where the numerator and denominator have been switched. While for a whole number, it'll be 1 over the number. Since a whole number can be written as a fraction divided by 1, basically they're saying if you have a whole number, you can make it into a fraction by putting it over 1. That's all that means. Okay, in the next lesson, you'll take a look at using the multiplicative inverse to help divide fractions, because it can essentially reverse the division in a fraction, leaving us with 1. We'll also end up using the multiplicative inverse as of fractions as we work with fractions down the road. Now, let's look at the division. Since fractions themselves are a way of representing division, we could represent dividing by fractions as a fraction. So 4 divided by 2 equals 4 over 2. 1 divided by 2 equals 1 over 2. Because remember, the fraction line, you just say divided by. That's what that means. So you have 1 divided by 2 divided by 2, or half divided by 2 equals 1/2 divided by 2. And the last problem right there in the middle of page 147, you've got 1/2 divided by 1/4. And that brings us to a problem such as this right here. Okay, you've got a fraction divided by a fraction. All right, now this is what we do. Let's look at 6.5, section 6.5. This is on page 148. All right, so I'm going to be right here underneath where it says understanding what we're doing when we divide. As we saw in 3.4, division means separating into 2 or more parts, areas, or groups. We also saw that because of God's faithfulness in holding all things together, division is consistent enough for us to memorize answers and divide using algorithms or step-by-step methods. So before we jump to how to divide fractions, though, let's explore the concept of dividing fractional quantities. Although fractional division can sometimes be a little more abstract, it too ultimately works because of God's faithfulness. Now, while we typically think of division as dividing a quantity into smaller parts, it's also the process of finding out how many times one number is contained in another number. We divide by 10 by 2, our answer is 5. tells us both what would happen if we took 10 and divided it into 2 piles, and also how many times 2 is contained inside 10, which would be 5 times. There's you a picture of the division to kind of get the picture in your mind. Okay, 5 is the result of splitting 10 into 2 piles, and the number of times 2 is contained in 10. Likewise, when we divide 6 by 2, the answer is 3. Not only tells us how many we will have if we divide 6 into 2, but it also how many times 2 is contained in 6. So it's telling us 2 different things. Now, the same holds true when dividing a fractional amount by a whole amount. We can look at the division as what would happen if we divided and as how many times one number is contained in the other. So look at the top of page 149 where all those cupcakes are. The first problem you have up there is 1/2 divided by 2 equals 1/4. Now this cupcake is showing you what that means. So you have half a cupcake. Dividing it by 2 equals 1/4, because if you have a half and you half it, you get 1/4. Each one of those is 2/4, so each is half. Okay, and then also half divided by 2 is the number of times 2 is contained in half. So only 1 out of 4 parts of 2, that's 1/4, is contained in half. There's you another picture right there in the center, and another one. Let's get down to the rule at the bottom. So how do we reduce division by fractions to something that we can do mechanically without having to draw diagrams? You've probably been taught to invert and multiply. Invert means to get the reciprocal and then multiply. So that's what we're going to do. So the example at the very bottom of page 149. Half divided by 4 equals half. Change it to times and take the reciprocal of the second number and then simplify. But why does this rule work? Let's step back for a minute and examine dividing fractions more carefully. So turn the page. Now, what that means is what we just did is we wrote the problem out just like it is here. We just wrote it out a little more easily. So now we're going to rewrite it. 1/3 stays the same. Now, we change this to times. And when you change this to times, you have to take the reciprocal of the second number. So the reciprocal of this would be 4/1. Then you can multiply. 1 times 4 is 4. 3 times 1 is 3. We get 4/3, but that needs to be simplified because this is improper. How many whole times does 3 go into 4? 1 whole time with how many left over? 1/3. So this would have been your answer on number 1 on worksheet 6.6. Okay, now what does this division really mean? So look at the top of page 150. When we multiply both our numerators and our denominators to get our answer. We can do the same thing in division if we have the problem where the numerators and denominators divide evenly. So here we have 8/6 or 8/6 divided by 2/3. Okay, so we could say 8 divided by 2 equals 4 and 6 divided by 3 equals 2. Your answer is 2. Now that was easy because all of those numbers divided down evenly. There's just one problem. Sometimes we run into fractions that don't divide easily, like 1/2 divided by 1/4. You can't do that. So following the same process as before, you would end up with a fraction in the denominator. That's what you would end up with. 1/2 divided by 4 equals 1/2. So that would be divided by each one of those. And you would end up, your answer would end up 1/2/4. And that can't be. We still haven't found a very useful answer, but remember how we learned that we can multiply any fraction by a fraction worth 1 without changing its value. Well, even though 1/2/4 has an additional fraction in the denominator, the whole thing is still a fraction. So we can multiply it by a fraction worth 1 without changing its value. So if we multiplied the fraction 4/2 divided by 4/2, the inverse of the denominator would cancel out. Multiplying by a fraction worth 1. So here we go. So they got the answer as 1/2/4. I'm at the bottom of page 150. 1/2/4 was their answer that they got by just simply dividing across. Okay. Now they're going to multiply this by 4/2 over 4 over 2, because that means 1. That would be the same as simplifying something down by just a fraction that just simply means 1. 4 over 2 over 4 over 2. That's 1. And then that equals, you'd cancel everything out, 4 over 2 over 1. Since any number divided by 1 equals itself, this leaves us with 4 over 2, or 2, because 4 over 2 is 2. The answer to 1/2 divided by 1/4 is 2. Notice we found the same answer we did with the cupcake illustration and with the invert and multiply rule. Now, all of this means this. If you took, rather than doing this, and you just did 1 divided by 1, and you just divide it across, okay, then you're going to come up with some crazy answer. You're going to come up with a fraction in the answer. You're going to come up with 1, because 1 divided by 1 is 1. And then in your fraction, 3 divided by 4, you're just going to come up with this. Okay? This can't be an answer. So what you would have to do then is you would have to multiply this by a fraction that equals 1. Okay? So a fraction that equals 1, you'd turn this upside down. You'd say 4/3 over 4/3. And then what we would do here is we would cancel these out. See, these cancel each other out, so you're left with 1 times 4/3. So basically, when you did all the simplification and stuff, you would get 1 1/3. Okay? So the reason that we don't just divide across is because it would cause us to have to do all this other work down here. So not to do that, that's why we changed this to multiplication and flip this upside down, because we would be doing that anyway. It would just take a lot longer. Okay, I think you understood that because you got several right, but you also got several wrong. So that's why I wanted to go over it. So I hope I wasn't just going over something you already know. But I just wanted to make sure that you understood that section. Okay, so you had missed A, which we decided was 1 1/3, because this was the original problem on A on worksheet 6.6. Okay, all right. Let me clear this out, and let me go back over here to letter C. So this was 1 1/7 times 4 over 5, 4/5. Okay, this is already multiplication. Now, first thing you need to remember is anytime in multiplication or division that you have a mixed number, you need to change that into an improper fraction. Remember how to do that? The shortcut, you multiply this, the denominator times the whole number, so that'd be 7, and then you add the numerator, that'd be 8. So then your new fraction would be 8 over 7 times, and then just bring everything else over. And you don't need the reciprocal, only if it's division. So you'll just bring this one over. Now, what we can do is we could see if any of these could cancel out. Does 5 and 8 have anything in common that they could be simplified down by? They do not. Neither does 4 and 7. So that means we're just going to simplify across. Since they can't, none of these can be simplified down, that means the answer we get will already be simplified. So 8 times 4 is 32. And then 7 times 5 is 35. Okay, so these can't be simplified. So this would have been your answer. The answer you put was 2 and 11/28. So I just want to make sure you remember. I think perhaps you may have forgotten to turn this mixed number into an improper fraction. Just want to make sure you remember how to do that. The denominator times the whole number plus the numerator. Okay, and then you keep this the same. That's how you do that. Okay. So on that same page, let's see, on number 2, factoring, let's see, on letters C and D. Okay, so we have to do the whole thing in order to get these correct. Okay, it says to express as a product of its prime factors. All right, so let me see how they wanted me to word that up there. Okay, so what you have to do on letter A is we're doing, and then B wants the prime factors for 89. So you got, okay, on letter A, it's expressed as a product of its prime factors. So its prime factors are, looking over here, I want to make sure I get you. Okay, so 24, its prime factors. If you did the factor tree, you would get, let's do 2 and 12. 2 is already prime, so just bring it down. 12 has, we'll say 3 and 4, and then 4 breaks down twice. And of course we bring these down. You keep bringing them down until you're all the way done. So 2 times 2 times 2 times 3. So you had put on your, rather than 3, you put 11. I'm not sure why, but you did. But anyway, you may have just gotten sidetracked or something there. So this would be 3. So here's your prime factors for that. Now on B, it says to express as a product of its prime factors. Well, 89 is already prime, so it would just be 89, which that's what you said. You got that right. Now on C, it says what is the greatest common factor of 24 and 89. Okay, now so what you would do is the common factors, they have none. So you put 1. So, and that's true, but we never use 1 because 1 is common to all numbers. So we never use 1. So 89 and 24, in my book, it says they don't have any common factors. So anytime you need to find common factors, just put your numbers like this. Sometimes it's 2 numbers, sometimes it may be more than 2. Okay, so what you'll do is you'll think of all the numbers that equal 24. We know 1. This is how my teacher showed me how to do it when I was in school. 1 and 24. Then you come back over here and you say, okay, 2. And what goes with 2 to make 24? 12. Okay, and then 3 and 8 and 4 and 6. Okay, so these are all of our factors for 24. 1 and 24, 2 and 12, 3 and 8, and 4 and 6, and that's all. But for 89, it's prime, which you already said that, so it's just 1 and 89. So yes, they do have 1 in common, but we do not use 1 as a common factor. It would have to be any other number besides 0 or 1. So they don't have anything in common. So on C, your answer then would be nothing, 0, nothing. They have nothing in common. All right, on letter D, it says, what is the least common multiple? That's the LCM. Now, these are factors. Factors are sets of numbers that when multiplied together, they equal a number. Okay, sets of numbers, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are factors, okay? Multiples means counting by that number. So if we count by 24s, so we could count, well, there's actually another way to find this out. So let's go ahead and look. I guess I better figure this out. This is going to take you a while to teach you that way. So let's look at, where was it that showed us the LCM? I think this was way back here. Yeah, this was way back here. We'll have to look. Let me look in your, let's see, least common multiple. Least common Yeah, I don't see where it says that, so I'll have to look back in your book. I wanted to be reminded. I know how to find the least common multiple, but I'm trying to remember the easy way that it taught you how to do it, because the only way I know how to do it is the hard way. So let's look here at the least common multiple. I'll tell you what we'll do. I'll just show you how to do this anyway. So your least common multiple is going to be this. You're going to take 24 and you're going to take 89. Now this may take a little bit longer than if I were to show you the shortcut, because if I showed you the shortcut, what you would do is you could write down their prime factors and then cross out those that are not the same and then just multiply what's left. But the way I like to do it is just count by the numbers until you get to the first number they have in common. So, but let's do it this way. Let's do their prime factors. Now we know that 89, the prime factors, because it's already prime, is just 1 and 89. Okay, so let's do this. 1 times 89. Okay, 1 and 89. All right, so the prime factors for 24 are 3 2s. I'm going to use a dot for multiplication. It's easier. And a 3. Now, what you do, actually, we do not use, we don't put the 1. We just put all the other numbers. Okay, so what we do is we cross out any numbers that are the same in both. They don't have them, do they? No numbers that are the same in both. So that means we have to multiply all these together. So 2 times 2 times 2 times 3 is 24. And then we would take 24 times 89. And so you're going to get a big number. 2,136 would have been the lowest common multiple. So if you did it my way, you would be counting by 24s. 24, 48, 72, whatever, all the way. You just keep counting up. And then you do 89 and whatever, then 89 plus 89, whatever the next one would be, plus 89, whatever the next one would be. So you count by 89s until you came to the first number they have in common, and it would be this number. So you'd have to count up a lot in order to get there. So an easier way to do it is to just find their prime factors. Put their prime factors here sort of like a fraction, and then you multiply everything together that's not the same in both. Okay? You'd like if this had some 2's here, you'd cross out, if it had 2 2's, you'd cross out these 2's, and then multiply what's left. Okay? It's kind of hard to remember LCM, but if you'll learn to just keep in mind, least common multiple. Multiple means to count by that number. So the least common of those is the number that's the least that they have in common. Okay? And then the factors of a number are those sets of numbers multiplied together that make that number. Okay? So that's a hard thing for kids to remember sometimes. Okay, so on section 3, you said here this was the multiplying and simplifying, and you said you needed some help on this one on your page. You left me a note. Okay, so let's go ahead and do this. This is section 3, multiplying while simplifying. Be sure to show your work. Okay, so it's 24 over 16 ounces times 46 over 16 ounces. All right, so this is basically multiplication. It is multiplication. Anytime the instructions say to simplify, usually that means just work out the problem and get the answer. Okay, now I'm going to put OZ, okay, times 46 over 16. And the thing says multiply and simplify. Pardon me. Now, an easy way to do it, I'm going to use a different color on this. An easy way to do it, to multiply, to make sure that the answer you get is already simplified and you won't have to simplify it, is to simplify the numbers that you're multiplying first. So let's look at, say, 24 and 16. You always have to do those that are opposites each other. So 24 and 16. What is a big number that they have in common? 8. They can both be divided down by 8, couldn't they? So let's try 8. So 16 divided by 8 would be 2. 24 divided by 8 would be 3. Okay. Now let's see if we can simplify these down. You always have to do crossways. Now 16 and 46 are both even, so I know for sure 2 goes into those numbers. So let's just try 2. 2 may not be the biggest number they have in common, but we can try it. Let me see what they have here. Yeah, let's try 2. So 2 goes into 16 how many times? 8 times. And 2 goes into 46 how many times? 23 times. Okay, now we've got some smaller numbers to work with. So now let's just multiply across and then see. It should be simplified. The only reason it wouldn't be simplified is if we didn't use big enough numbers on here. So 3 times 23 would be 69 over, and then 8 times 2 would be 16. Okay, now we know for sure we need to simplify this down, and we need to make this into a mixed number. So we'll say, how many whole times does 16 go into 69? Well, let's just do some division here and find out. Now, the number that you get up here is your whole number, so that'll be your big number here. Okay, the remainder that you get over 16 will be what's left. Okay, so 16 goes into 69. How many times? Let's see, if we say 4 times, let's say 4 times, because 3 times is only 48. 4 times 6 is 24. 4, 5, 6. Perfect. So we have 5 left over 16. So our whole number then would be 4 whole and 5 sixteenths. Make sense? That's how we would do that one. Okay, so on B, let me see if I can help you with that. 4 sixteenths. I know this video is too long, and I apologize. Take your break anytime you want and come back to it. Okay, now these two can cancel each other out, right? They go into each other one time, right? Just mark those out and put a 1. Now multiply across. 4 times 1 is 4, and 1 times 1 is 1. Well, we know what that is. It equals 4. Okay, all right, so on C, you have 20 over 16 times 16 over 1, which is the same as just plain 16. These can cancel out, can't they? They each go into each other one time. 20 times 1 is 20. 1 times 1 is 1. Your final answer then would be 20. Does that make sense? Okay, so anytime it says to cancel, that's what it's talking about. It didn't say cancel, but that's what you can do on those. Okay, good deal. So I think that was all of the problem that we had on that one. On, okay. I want to go ahead and we'll just close this video out, and I'll make a new video so you can do it the next day or whenever you want to, so that the videos aren't too long, okay?